Good afternoon, everyone. I think I'm going to go ahead and get started here. If you guys can't hear me that well, just let me know. If you want to type in something in the chat window there, I can take a look at it, but I think everyone should be hearing me just fine. Again, as I mentioned, thank you everyone for joining me. My name is John Elfie. I'm an applications engineer here at Heat Pipe Technology. Today's webinar is going to be primarily around SelectPlus, and that's selecting our wraparound dehumidification units, what we call U-frames, or DHP-U for shorter. Again, if you guys have any questions or any comments, if you want to type them into the chat window, and at the end, I'll go through all the questions, answer as much as I can. Whatever I can't get to or I can't answer, or maybe something that's more job specific, I will reach out to you guys one-on-one and answer all the questions. So let's move on here. Before we begin, if you guys haven't already signed up or registered for our selection software, I would definitely recommend it. I'm just going to do a couple of examples on our software. I'm going to go really slow. If you guys do miss anything, this webinar is going to be available on our website here coming up shortly. So you guys can always check it out if you missed something. But if you do want to register, just go on to heatpipeselect.com. You can click to request a user account, fill out all your info, and then once you click submit, you're going to get an email with a link to set up a password. So it's very straightforward, very easy, and you'll be registered in the same day, within a couple hours. All right, so a little outline of what I'm going to be discussing today. First off, I'm going to start off with what are heat pipes. Some of you may not be familiar with the technology, so I'll get a little into it. I won't get too heavily into that aspect of it, but I will just kind of cover it briefly. And then I'll go into what is a U-frame or a DHP-U. Again, some of you might not be familiar with the technology. I'll kind of go over what a U-frame looks like, how it's installed, and other forms of a wraparound that we actually offer here at Heat Pipe Technology. And then I'll go through and do some selection examples. Again, I'm only going to do two examples. One's going to be a controllable version of the wraparound, and the other is going to be the non-controllable version of the wraparound. And then also what to look out for when selecting U-frames. There are some things to consider with dimensions, with valves, power supply, all that stuff. So I'll go into that as well. And then I'll do estimated savings using bin data. And then I'll wrap it up with some tips and shortcuts to kind of help speed the process when you're doing selections. All right, so moving on. What is a heat pipe? So in our case, a heat pipe is a copper tube that is sealed, has refrigerant inside, either 134A or 410A. And if heat is applied to one side of the heat pipe, that refrigerant is going to absorb that heat, it's going to vaporize, move over to the cold side, where it's going to condense, then turn into a liquid. It's going to give off its heat, turn into a liquid, travel back down to that hot side, where the cycle is just going to repeat itself over and over again. So imagine if you take this heat pipe and you divide it with two separate airstreams, a hot airstream, let's say at 90 degrees Fahrenheit, and then a cold airstream, let's say at 55 degrees Fahrenheit. On that hot airstream, as it hits that heat pipe, the refrigerant is going to absorb that heat and vaporize, and the air leaving the other side of the heat pipe is going to be cooled down. Now on the opposite side, on that cool side, that cold air coming in contact with the heat pipe, it's going to cause the refrigerant to give off its heat. It's going to condense and again travel back down to the hot side. Now that air on that side, what it's going to do is absorb that heat and it's going to heat up. So if you take this heat pipe and sort of bend it into a U shape, what you're going to get is a U-frame. And if you actually place that U-frame around a cooling coil, you're going to have that hot air stream, which could be outside air or return air, and you're going to have that cold air stream, if your cooling coil is energized, it's going to come into contact with the heat pipe, and it's going to cause the refrigerant to condense. So that's basically what a U-frame is, or what a wraparound is. What it offers is pre-cooling outside air or return air, and on the downstream side of the cooling coil, it's going to offer reheat. So in some instances, what we can actually do is completely replace either gas or hot water reheat or supplement, so you're not as dependent on those two forms of reheat. So it definitely has its advantages. Another advantage is it's going to be a compact design when you compare it to other technologies. And to give you guys an idea of what it actually looks like, this is a U-frame. This is actually a picture of a U-frame that we have in our demo. And this is exactly what you would be getting. This is like a ready-to-install unit. And as you can see here, the way it would work is we would ship it out to a manufacturer. It's installed by them. As they're building the air handler, they would just place it over the cooling coil, secure everything, do flashing, whatever is necessary, and then seal up the air handler. And that's basically it. So again, it's prepackaged, ready to install. It is installed by others, and that's basically it. Another form of what we offer with wraparounds is actually factory or site retrofits. Factory being where a manufacturer is actually going to ship us a cooling coil section, and we're going to do the installation here and then ship it out to wherever they need to. But again, they do have to take into account that we do require some space. If you guys can see my pointer here, and I hope you do, there is if you were to look at this heat pipe, assume that airflow is kind of diagonal, right to left. This is going to be your pre-cool side, and downstream here is going to be your reheat side. And the cooling coil is going to go between this span here. Now this span can actually be adjusted. The minimum is 12 inches, but we can actually go up, in some cases, up to 100 inches or even more, depending on your fin length. And this section here is what we call our crossover tube section. It connects the pre-cool to the reheat. Now this is just a physical limitation that we have. We have to connect the two sections together. So we do need some space, and it's going to be on the back end of the unit, on the U-bend side of the cooling coil, where this section would go into. And it would be all encased inside the air handler walls. So again, this is just giving you just a quick idea of what a U-frame actually looks like. We do have, like I said, different variations of it. We do also do site retrofits, where we're going to go to a job site and retrofit existing units. It's not as straightforward, though. We also have to take into account that we're going to send our techs out, so pricing can be a little bit different. And sometimes with old units, we're not going to have the space that we need to actually retrofit a unit. So we're going to do an inspection trip, make sure that everything looks okay, and that we can actually do our thing. So anyways, if you guys have any questions, again, feel free to type them into the chat window. I see that I got one, and I will definitely get to it here at the end of the webinar. So moving along, what I'm actually going to do is get into SelectPlus. So if you were to sign on to SelectPlus, this is what you would see. This is a list of the projects that you have, and you can actually just keep adding projects if need be. What I'm going to do is show you an example. I'm just going to do, I hope you guys can see my cursor here, but I'm going to do just a test project. Type in your name. Click Add New Project. Oh, that already exists. Let's do test 3. Add new name. And then here you can actually fill out all the info that you want. I mean, it's just a reference for you down the road if you want to, see where the location was, if you don't remember, or where the engineering was done out of, all that good stuff. The project type, different categories. You can also here set your units, either metric or IP. And once everything looks good, just click Update, and it's going to update and take you to this screen here. So as you can see there, I created a test 3. But for the purposes of this webinar, I actually created a project here. It's called the U-frame webinar. And to get into the actual selection, what you want to do is click this open schedule icon. So I'm going to click that. And to select a wraparound or U-frame, what you want to do is make sure that the product type shows wraparound. Because we also offer heat recovery, and that's obviously not what we're doing today. So we're going to click wraparound. And when you want to add a new line item, just click Add New Line Item. All right, so this is the screen that you're going to see next. You're going to see that we created a new line item. To get into the selection itself, you're going to click this Select Item icon. And here you go. This is going to be your main input. So what I like to do is just start from up top, left to right, and then kind of work my way down. Now, when you get into controllable units, it's going to be a little different. There's going to be a little a different step that I want you guys to do, just so you make sure that you don't make any mistakes. But for this first example, I'm going to do a non-controllable unit, and then I'll do another example with a controllable unit. So, quantity, you can always change the quantity, anything that you want. Tag, I'm just going to tag this as non-controllable. And then the type, again, I mentioned that we have U-frames or factory installed. Factory installed, the only difference is when you get to the drawing, the dimensions are slightly different because we don't have casing, for example, for the crossover tube sections. It's just going to be the bare tubes. So the dimensions are going to vary a little bit, and the drawings are going to look different as well. But again, we're doing a U-frame. Here towards the center, you can select the tubes. Not a lot of options here. We actually only offer half-inch tubes. Fin material you can change between copper and aluminum. Probably 95% of the time we do aluminum fins. And then also, if you want to change the, sorry guys, for some reason it's not showing me the, anyways, fins per inch for some reason right now it's not showing me all the numbers that we have. We actually have from 9 to 14 fins per inch. Let me see if I change something here. No, it's being stubborn. All right, let's try that. There we go. All right, so you can select anywhere from 8 to 14 fins per inch for aluminum. For copper, it's different. For copper, it's either 10, 12, or 14 fins per inch. All right, so moving down the line, refrigerant, we can either select 134A, 410A. That's what we offer here. Coating, we can do either no coating, electrofin, or hair site. And if we move on down here, we can actually do air type now. You can do standard, which is at sea level, or actual, where you can actually list an elevation. And performance is going to be affected depending on elevation. And here you would choose your control option, but again, I'm not going to do this right now. I'm going to do it in the next selection that we do. All right, so getting into the dimensions. A rule of thumb, what we do here is typically just size based on the cooling coil dimensions. So if you have a fin height and fin length, I would just input those dimensions. If you want to stray away from those dimensions, that's fine. If you have more room to make our heat pipe bigger, making the face area bigger, you're obviously going to get more performance out of it. Decrease the face velocity through the coil, which is going to lower your static pressure. So if you want to do that, you can always go ahead and do that, but typically I just size according to the dimensions of the cooling coil. So in this case, I'm just going to do, let's do a 40-inch fin height and a 50-inch fin length. And let's do 2 rows for now. Now moving down, you can actually do a different type of entering air, the pre-cool. So you can do entering mixed air, if you already know the value, 100% outside air, and then we also have a calculated mixed air that we can enter in the outside air, the CFMs, temperatures, and then the return air, same thing. And then it's actually going to calculate what that mixed air temperature is. And that calculation is going to be shown here. But for this one, I'm just going to do, let's do 100% outside air. I'm going to come back up here, change this to standard. And let's do a 5500 CFM unit. See conditions, I'm going to do 9072, which I believe is Tampa design conditions. And then that's your entering pre-cool. I mean, again, that's your hot air stream where your refrigerant is going to vaporize. So you're going to be doing pre-cooling there. And then if we go down here towards this input here, that's going to be the leaving air temperature of your cooling coil. Now you can do either temperature or fixed capacity and BTUs. I'm going to do temperatures to tell you what we see. I'm going to do 55 degrees and 54.8. And then here you have your span. I would definitely recommend that you are accurate as possible, or precise as possible, as much as you can be in the beginning with your span, because we actually have limitations with the span. And it's dependent on a total circuit length. So we have a total circuit length limitation that if you were to input, let me see if I can make it actually give me a prompt. Say you want a 120-inch span. I don't know if you see this little asterisk here. If I try to click calculate, it's going to give me a prompt. So it's going to give me a limit that I can't exceed, and that's based on the overall circuit length. So you want to make sure that you're as accurate as possible. So down the line, if it starts getting to a phase where you need something more concrete, the design, and you can't do the span that you're looking for, then you're going to have it's going to be an issue actually trying to make whatever you had work. So I'm going to do 24 inches. And I see that since I'm here, I see that I had a question, and one of the questions was, with a U-frame, how do you clean the chilled water coil? So this is one way you can actually do it. If you have a large enough span, you can actually put access in between the pre-cool and the cooling coil and the reheat and the cooling coil to actually get either somebody in there or either get a pressure wand in there to do any kind of cleaning or maintenance. So you can actually modify that span to give yourself enough room. All right, so we have everything input. Everything looks good. I'm going to go ahead and click Calculate down here. And this is the results. Now you can see everything that you need to see is shown here. You have your air velocity. You got your entering and leaving pre-cool conditions. You also have what reheat you're getting out of. In this case, it's almost 64.5 degrees. And then down here, you have other information. You got your pressure drop per coil. That's 0.17 inches in the pre-cool, 0.16 on the reheat, and your effectiveness. If you don't like something here, what you can do is just go down here to the bottom and click Reselect, and it's going to take you back to the screen. And you can change whatever you need to, click Calculate, and just go back and forth. Within this screen here, we also have a psychrometric chart, and then we also have a economic analysis. So I'll get into the economic analysis here in a little bit. The psych chart, I'll show you what that looks like. There's your psych chart if you want to get an idea of what it looks like psychometrically. Then we click Go Back. And now we are going to continue. All right, so this is your drawing screen. This is going to list your overall dimensions. So you got your total overall width, overall height, your span here, and it's going to give you your weight. I don't know if you guys can see this here. Casing material. If you want to change casing material, you can actually do it in this screen. If you look up top here, we either offer galvanized or stainless steel. And then two, you can actually modify the number of sections. We have a max overall fin height per section of 60 inches. So if you were to select something at 70 inches, it's going to go to 2 sections by default. In this case, if I want to do 2 sections high, if you look there, the heat pipe is not 2 sections tall, 2 coils. They are separate. When they ship, they're going to be separate, and you would just stack one on top of the other. And then another very important dimension to notice, which I kind of pointed out when we saw the picture of the U-frame, is this dimension right here, this 2-inch dimension. I hope you guys can see my cursor here. But this is where the tubes actually run from the pre-cool. If you're assuming that this is the pre-cool and this is the reheat, the uppermost coil or section, the connecting tubes are actually running across, and you need the space inside the air handler for that section. With factory installs, it's a little different. Instead of 2 inches, we might be able to get away with for a 2-row 1.5 inches because we don't have casing. So again, it's something else to look at if you do want to do a factory install. Definitely take into account the design changes that you need to make, because at the end of the day, what we want and what you guys want is installation to be as smooth as possible. We don't want to have to do any kind of modifications. If we need to, we will. We'll always work with you guys. But in order to get things out of here as quick as possible and to avoid any kind of potential issues, definitely take into account all these dimensions. You have your coil width, which in this case is 3.25 inch. So we don't take up a lot of room upstream or downstream. But again, I can't say it enough, this dimension here is the most critical, this 2 inches in this case. Now the higher you go in rows, obviously that's going to change because we're going to need more tubes to connect those rows. So what I actually do really quick is I'm going to click back up here, go to Reselect. Let me change this to 4 rows just to give you guys an idea. Do 4 rows, calculate. You can see the reheat, we're performing more. We went from 64.3 degrees to now a little over 69 degrees. And your effectiveness went up as well, so now we're at 40% effectiveness. As before, we were a little bit above 26.5% effectiveness. So if I click continue, you're going to see that the coil width changed. Now it's 5.5 that we're going to need upstream and downstream minimum. And the section here for the crossover tubes actually went out to 3.5 or 3.25 inches. So we're going to need more space on that U-bend side of the cooling coil. So that is pretty much it for the non-controllable. What I'm going to do now is actually move over to a controllable selection. So if everything looks good, what you can click here is do save and close or save and U. I'm just going to do save and close. It's going to take you back into this main screen, and I'm going to add a new line item. Again, open up the actual line item by clicking select item. I'm going to start up top. Let's change the tag. Let's do controllable. It's already here. Let's do 12 fins per inch. I'm going to keep it aluminum. Still doing a U-frame. And when you get to this part, before I kind of told you guys to work left to right, top to bottom, with control valves, I would definitely recommend that you wait until you actually input your dimensions, because if you take a look now, we offer either 24 volt valves or 120 volt valves. However, the 24 volt option is actually dependent on the number of valves, and that's dependent on the fin height. So the higher the fin height, the more valves you're going to have. And we actually cap the ability to have 24 volt valves. I think the valve count is 22 valves. If you have a unit that has more than 22 valves, and again, that's dependent on the fin height, you actually won't be able to select the 24 volt option. And the reason why we actually do that is because anything above 24 volt valves, it's going to require a huge transformer, and actually the load on the terminal strip that we provide with these units is going to be too much for what it's rated for. So to give you guys an idea, let's say I do, we do the same dimensions, 40 by 50, 2 rows, and then I go up here and select control. You can see here that the 24 volt option is actually, it's shown that I can select it. So I can select that if need be. However, if I go back to non-controllable, let's say I change this to 90 inches. No, that didn't work. Let's do 120 inches. Now if you look up here, the fin height is 120 inches, but I can't select that 24 volt option. The reason why is because it's too many valves. It's exceeding that 22 valve count, that threshold. So now I'm only left with the 120 volt option. Now say I did, let me zero this out. Now say I started up here, I didn't input any dimensions, and I clicked 24 volt. If I were to do a fin height of 120 inches, so if you look back up here, it actually went back to standard non-controllable because 24 volt is not an option. Now sometimes what a lot of people do is they think they just keep moving along. They think they already selected that option, click calculate, and that's going to be their performance for a controllable unit, and it's not. There's actually going to be a drop in performance, or there's going to be an impact on performance if you add valves, and that's because there's added resistance for that refrigerant to flow to make that loop around the circuit. So anyways, I definitely recommend, again, always starting with dimensions first and then selecting your valves. One thing I didn't mention with valves is, let me do 40 again, 40 inch fin height, 50 inch fin length. If I want to do 24 volt, we have options. It's either 3 stages or 4 stages. Depending on the level of control that you want. If you want finer control, you would go with 4 stages, or you can actually do 3 stages if you don't want as precise control. If you want to request 2 stages, that's fine. That would have to be done in-house. You would just have to get with us, and I can work it out for you as far as doing 2 stages. So I'm going to leave it at 3 stages. And keep moving on here. I'm going to do 9% outside air, 5,500 CFMs, 90, 72. Same conditions as before. 55, 54, 0.8. And the span I'm just going to leave as is. I mean, you can, let's change it. Let's do 36 inches in this case. Say we wanted to get room in between our coils and the cooling coil. And click Calculate. Again, this is your results. Now if you take a look here, you see that hit on performance. And again, this is because, one, it's actually two reasons. One is because there's added resistance due to the valves actually being placed. But two, we actually combined rows. We combined 2 rows into 1 row so that we have less valves, because we have looped circuits here in these heat pipes. So we actually have a liquid line and a vapor line. The vapor travels in one direction and then makes its way around, and the liquid travels in the other direction. So we actually combine rows so that we have less liquid lines, which is where the valves are placed. And that decreases cost, number of valves, power requirements, all that good stuff. So now you saw that hidden impact. Before, with the non-controllable, we're looking at a little over 64 degrees, and now we're looking at 63 degrees. So that is something to keep in mind. Again, if you made that mistake of thinking that you selected control valves or controllable units, and you went through and you actually didn't, performance is not going to be the same. So definitely make sure that you have selected those control valves. All right, so I'm going to click Continue to get to the drawing screen. And here you go. So one thing to notice is this dimension here actually went up. Before, we were looking at 2 inches that we needed, and that was only because there was only tubes that were in that section. But now we actually have valves. The valves actually are placed right here in the middle of this section, if you guys can see my cursor. So that's why we actually need more space, because the valves are all right there. And what we're going to provide with the units, which you couldn't see in that picture in PowerPoint, is there's actually a movable panel, which is going to be on this back end here. It can actually be removed, and the valves can be accessed if you need any kind of maintenance. Now, with air handling units, we would definitely recommend that on this side of the unit, that there would be some kind of removable panel or access door, so that you can actually open that air handler and then get to our service panel here. So that's another thing to keep in mind. So that's pretty much it as far as controllables. That's what I wanted to point out. Again, very critical of this dimension here. A lot of times we get people that were not aware of this dimension, and there's issues actually going back and kind of tweaking things because things have been designed already. There's not enough room. So it could be an issue, but everything's always workable. We can always work around it. So. All right, I think that's about it for this. Actually, one thing I didn't mention, which is very important, is the airflow direction. These units are only going to work in the specified airflow direction. So if I were to click right, the way we do handling is airflow hitting you in the back of the head, and the side that these crossover tubes are at, that's going to be your handing. So in this case, air is hitting us in the back of the head, and the tubes are on the right-hand side, so this is right-handed unit. And again, it's very important to get this correct, because these units are only going to work on the specified handing that you choose at this point. If you wanted to say flip this heat pipe around, it's not going to work. And the reason why is because we actually slope the crossover tubes from the pre-cool to the reheat section, so the vapor actually travels upwards and the liquid travels downwards. Gravity helps us with that refrigerant flow. All right, so I think that's it. I'm going to move on. Now I'm going to get to savings analysis. So I'm going to jump back into my original selection, just this non-controllable, and click Calculate. And I'm going to get into the economic analysis right here. All right, so this is pretty straightforward. Just follow the steps. You guys can see here the steps in red, 1, 2, 3, and one that's typically missed, and I'm not sure why it's all the way here to the right. I didn't have anything to do with the design of this, but we're going to be doing some tweaks. This is step 4, so don't forget to do the step 4 here on the right-hand side. But start off with choose city. I'm going to go crazy here and do Tampa, Florida. Tampa, Florida, click apply. Step 2 is going to be your runtime. You can choose whenever you want, depending on the application. In this case, I'm just going to do 24/7. If all that looks good, step 2, then go to step 3 and click load bin data. And this is your bin data here. I'm going to choose a range of temperatures. And once you're good with that, going to move on to step 4. What it's going to do is actually carry down the airflow and the temperature leaving your cooling coil. It's going to duplicate it all the way down. If you just skip that step and go to calculate economic analysis, it's not going to be accurate, obviously. All right, so if all that looks good, click calculate economic analysis. And here you get into your input for your reheat type and rates. You also have other inputs like EER, your fan efficiency, if you know all that stuff. This here is always default. We have gas at 79 cents a therm, hot water at $1.10 a therm, but you can always change that. But you always want to make sure that the reheat that you're choosing, it's either on hot water or gas and fuel. Typically, we don't see electric because that's a no-no according to standards now. But you can always choose type in electric rate for cooling because you are going to get pre-cool savings. But you want to make sure that whatever you reheat, what type of energy that you're using, or the type and the rate, that you leave it selected at that input. So in this case, I'm going to do hot water and $1.10 per therm. And again, if all that looks good, down here you can click calculate. Down here on the right-hand side, the green box. And this is going to be your results. You're going to see pre-cool savings. This is going to be net savings. So it does take into account static pressure due to our heat pipe coils. And you can actually see the static cost. So this is pre-cool. This is reheat, assuming hot water at $1.10 per therm. And this is your overall net savings per year. Now, if you want to do an overall cost, say of the heat pipe, then you can actually get a return on investment. So in this case, I'm just going to leave it as is. And I think that is pretty much for the screen. I guess I'm looking over here to the chat screen. Nobody has any questions. Guys, remember, if you have any questions, just type them in there. I guess no one does, so I'll keep moving along here. All right, so if all that looks good, we're going to go ahead and hit calculate, which I already did, and click continue down here at the bottom. And it's going to take you to your drawing screen. All right, so that's economic analysis. I don't know if you missed anything, if I went over anything too quick. Again, this is going to be available on our website probably this week. If not, we do have a YouTube channel where you can actually see all this stuff. 2 to 3 minute videos, so it's not going to take up a lot of your time, and it'll definitely be helpful if you have any questions. So save and close. And now I'm going to do some shortcuts or some tips. One of the things that I find very useful is before, when I was doing another selection for a controllable unit, I actually clicked add new line. But if you want to speed things up, what you can actually do is you can select whatever line item it is that you want. Say you want to do one, you already have dimensions, you just want to do different conditions or a different number of rows, maybe different fins per inch. You can just select that line item, and down here at the bottom, there's a little copy to button. Just click that, and it's going to copy that selection over. So then you can just jump into it, and there you go. Just do whatever you need to. So that's one tip that I find is very useful. If you want to, you can actually select all of them, copy to. It's going to copy everything over, and then you just change as needed. Another really cool thing is if you have a different project name, different application, what you can actually do is if you have a unit that's similar size or conditions, you can actually select whatever you want here in one project, and right next to the copy button, don't click copy, just go next to it. There's a drop down. It's going to give you a list of the projects that you've created. So you can actually create a project beforehand, save it, jump into your selection where you want to copy the line item from, and say, I like these two line items here. I want to copy them over to test 2 project that I created, or test 3, the one that you guys saw. Copy to. And what I'm going to do is down here at the bottom is actually return to projects tab, or a little button. Click that. Now if I go into the test 3 project, those 2 selections are going to be there. So now I can just change the selections. I don't actually have to input all the dimensions and conditions and all that stuff. So those 2 tips I find are very helpful and definitely speeds the process of selecting. All right, so let me jump back in. The last tip that I want to show you, or shortcut, I guess maybe feature, is this little submittal icon. It's a toggle switch. If you want to output a submittal, like an official submittal document, instead of having to output every single line item, which this was the case, I believe last year, we didn't have this option. So if you want to do submittal, it would actually spit out every single line item. And sometimes you don't want that. Sometimes you just want to output one line item. So whatever you don't want to output, just toggle this to no. So I'm going to leave these 2. And up here at the top, there's a little submittals icon, if you will. I'm going to click that. And it's going to take me to this screen. And within the submittal, you can actually output whatever it is you want. So actually, let me go back. Let me make sure that I output a bin analysis that we did so you guys can take a look. And we did that for the non-controllable, so that's selected. So I'm going to do design performance, bin analysis, and drawings. And you can save to PDF. I wouldn't recommend saving to Word because the format of the Word document is kind of weird. That's something that we're working on. If you ever need to add anything to that document, it'd be very helpful to have that Word document, but right now we don't. So, all right, so the PDF is downloaded. I'm going to open it. I'm using Chrome, so it's down here. And there you go. Those are the 2 line items. And you can see that they're both controllable, the ones that I selected. If you scroll down, there's the order code to kind of break down this order code here, if you're not sure. That's page 2. And this is going to be your results, your performance. Performance for the other unit. You got drawings. And I didn't get the bin analysis. I thought I selected it, but what we can do is, here's the drawings. Maybe I didn't select it. What I'm going to do is close out of this. This is one way of getting performance if you want. But another way that you could do is actually, let's see, open that selection back up. Non-controllable, I forgot. I selected actually the wrong unit. So this is the one that we did a bin analysis for. This one here, the first one. So you can actually output individual reports. If you click that little icon there next to the schedule icon, and I'm going to output a bin analysis. Click report. And there you go, there's the bin analysis. You can actually save this to PDF file if needed. And this is going to give you your results. And down here, if you take a look, that's your net savings per year. So it's going to break down in a PDF form what the results are. I think that's pretty much it with the bin analysis and the reporting, submittal, all those other features. I hope that stuff is helpful. Again, if you guys have any questions, I see I have some questions here. So let's see. Somebody's asking for budget for 100% outside air recoil. That's something that I can definitely get with you one-on-one because it's dependent on number of rows, first off. And there's a couple of other factors. But again, if you want control valves, it's another factor that's going to change cost. But I will definitely get with you one-on-one on that question. And then also I had somebody who actually couldn't hear what I said. So again, this webinar is going to be available, and you can't hear what I'm saying, so it's probably not going to help. But I'm going to type that in. And guys, that's pretty much it. I'm not going to keep you guys anymore. Any other questions? Just you can actually, I'll stick around for a little while, and I'll just type in answers. Again, if you need to reach out to us for anything, feel free to do so. Again, my name is John Elfie. This webinar will be online here shortly. Thank you guys for watching, and I hope you guys have a good 4th of July weekend. Thanks.